So we had discussed the Fraunhofer diffraction pattern for a single slit and a circular aperture. Now we'll see that what will be the Fraunhofer diffraction pattern for a double slit. So instead of one slit, if we use two slits of equal width. So as you can see, there are two slits. Okay, so this is first slit AB and this is the second slit CT. Okay, and both of them have the same width A. Okay, and these two slits are separated by an opaque space BC. Okay, whose width is B. Okay, so we can say that separation between the two slits is BC. So the distance between identical or corresponding points is D equals to A plus B. Okay, so what is the identical points or corresponding points? So the corresponding points means the equivalent points in the slits. Okay, so for example, if you consider the topmost point of the first slit AB, which is this one, and if you consider the topmost point of the second slit CD, which is this one, then these two are corresponding points or equivalent points because both are the topmost point of the two slits. Okay, and what is the separation between them? It is, you see, A plus B, which is denoted by D. Okay, similarly, another example of corresponding point is if you consider the midpoints of the two slits. So suppose this is the midpoint of the first slit and this is the midpoint of the second slit. Okay, then again what are their separation between these two equivalent points or corresponding points? You see, so this much distance is A by 2 because it is the half of the width of the slit. Then we have B, so A by 2 plus B plus this much distance, which is again half of the width of this second slit, which is again A by 2. So it is A by 2 plus B plus A by 2, which is equal to A plus B. Similarly, another example of a corresponding point is if you consider the bottommost point. Okay, this one and this one of the two slits. Then again the separation between these two corresponding points are B plus A, which is again equal to D. Okay, so the corresponding points mean the equivalent points in the two slits. Okay, and the separation between each corresponding points or identical equivalent points is D equals to A plus B. Now you see, as there are, instead of a single slit, there are double slits. The intensity pattern will be affected by two factors. Okay, so there will be obviously when the rays are passing through the slits, they will be diffracted. Okay, and they will reach different points on the screen. So this is the screen. Okay, so here if you look at this diagram, so some rays which are not diffracted after passing through the lens, as usually they will be focused at a point on the screen which will be the center. Okay, so here we will get the central maximum as usually. Okay, so O prime is the center of this opaque space. Okay, so O prime will give us the central axis of this whole setup, you can say. Okay, so the rays which are moving undeviated or undiffracted after passing through the lens, they are focused at point 2 on the screen, which will be the position of the central maximum, and of course it will be the the most bright point. Okay, but now there will be other rays which are diffracted by different angles. So here we are showing the rays which are diffracted by this angle theta. Okay, so here we are showing 4 rays, right? They are numbered 1, 2, 3 and 4. So you see the first and second ray which are coming from they are coming from the same slit AB. Okay, and this third and fourth ray, they are also coming from the same slit AB and they are reaching the same point B. Okay, so and there will be other rays between the points A and B and C and D which are diffracted by the same angle theta and they will be reaching point B. Okay, so at point P there are rays coming from different slits. So there will be interaction between among the rays coming from the same slit, like the rays coming from the slit AB and the rays coming from the same slit CD, and also interaction between the rays coming from the two different slits. Okay, so there will be interaction between 1 and 2. They will interact, these two interact will some way, then 3 and 4 and the other rays in between will interact among them, and there will be interaction between 1, 2, 3, 4, that is the rays coming from different slits as well. Okay, so we know the rays which are coming from the same slit means they are coming from various points on the same wavefront. Okay, so these rays, okay, which are coming from the same slit, they are coming from the various points, secondary source points on the same wavefront. So they will interact each other, and the phenomenon is known as diffraction. Okay, similarly the rays which are coming from the second slit CD, that is coming from the same different points on the same wavefront, when they interact we call it diffraction. Okay, so there will be diffraction between the rays coming from AB and also among the rays coming from CD. But again, the rays not only diffract among themselves, but also not only interact among themselves, but also interact with the rays of the other slit. That is, the rays coming from AB will also interact with rays coming from CD. Okay, so what we'll get? We'll get the interaction between the rays coming from two slits. So it is similar to the Young's double slit experimental arrangement. So what we'll get? We will get the in addition to diffraction, we'll also get the interference phenomenon. Okay, so the intensity at point P will depend upon two factors. One is the diffraction due to single slit. Okay, AB and CD. Okay, separately they are interacting. The rays coming from AB interacting among themselves separately, and the rays coming from CD also interacting among themselves separately. And also there will be interaction between the rays coming from AB and CD also. So these 1, 2 rays will interact among themselves. 3, 4 will interact among themselves separately. But again, this 1, 2, 3, 4 will also interact with each other. Okay. So the interference pattern will depend on two factors. Okay. So one is the diffraction due to the single slit, and the interference of the diffracted rays from the two slits. Okay, so the rays which are diffracted from the single slit individually, they will produce the diffraction pattern, and the rays which are diffracted from the two slits, they will also interact with the diffracted rays from the other slit, and they will produce the, when they will reinforce each other, they will produce the interference pattern. So we can say that there between the rays 1, 2 and 3, 4. So 1, 2 will give us the diffraction pattern. Similarly, 3, 4 will give us also give us the diffraction pattern when they interact, because they are the rays coming from the same slit. Okay, but when rays 1, 2, 3, 4 interact, we get the rays coming from two different slits. Okay, so 1, 2 and 3, 4 will get the interference pattern. Okay, so the interference pattern in the intensity distribution function, if we find the intensity distribution function, so it will depend on the two factors. Okay, and we will get the two terms. Okay, so the first is the intensity due to the diffraction. Okay, which will produce its own diffraction pattern, and the intensity factor due to the diffraction is given by 4a0 square sine square alpha by alpha square. So we know for a single slit it is a0 square sine square alpha by alpha square. Now there are a diffraction for two slits. Okay, two individual slits. So that's why over here we have got the 4 factor. Means there are square of the 2, because there are two single slits. Okay, so that's how we have got the 4a0 square sine square alpha by alpha square. Okay, and there also the second factor on which the intensity function distribution function will depend is the interference, right? So the interference factor, the intensity due to interference will depend on the term cos square beta. Okay, so what will be the net intensity at any point? It is given by I equals to the product of these two factors. Okay, so it is 4a0 square sine square alpha by alpha square into cos square beta. So what are these alpha and beta? So we already know that alpha is pi a sine theta by lambda, which is for the single slit. We have already found the expression in the single slit pattern. Alpha equals to pi a sine theta by lambda, where theta is the angle of diffracted ray, a is the width of the single slit, and lambda is the wavelength of the light employed. And now what is beta? Beta comes for the interference. Okay, so here alpha comes for the diffraction, so we have a the width, and beta comes for the interference. Okay, so that's why it will be pi into a plus b sine theta by lambda. Okay, so a plus b is the interference. A plus b is the separation between two corresponding points. Okay, so it means that here this point over here, the corresponding points A and C will interfere with each other, and the corresponding rays coming from the corresponding points B and D will interfere with each other. So it means that the 1 and 3 are corresponding rays, again 2 and 4 are corresponding rays. Okay, so that's why they will interfere. Okay, so we can say that in the interference, these 1 and 3 they are being corresponding rays. They interfere. Okay, and the 2 and 4 they are also being corresponding rays, means they are coming from the corresponding points. And you see, and the separation between, so here the slit width is the separation between the corresponding points, which is D equals to A plus B. Okay, so you can say that the point A and point C, where the rays 1 and 3 are coming, the point A is like a point source, point C is also like a point source. They are separated by a slit of D equals to A plus B, that is the separation between the corresponding points. Okay, those two interfere. Similarly, again the point B and point D are corresponding points. Okay, so these are coming from A and C, these are coming from B and D. Okay, so these two rays coming from the corresponding points B and D, they act like a point source. Okay, so and the separation between those two point sources is again slit equals to D equals to A plus B. So in this case, if you compare it with the Young's double slit experiment, then the slit width would be D equals to A plus B. So that's why here this beta equals to pi into the slit width, okay, which is A plus B into sine theta by lambda. And the diffracted rays are also diffracted by the same angle theta, and then they interfere. Okay, so that's why we have this sine theta and this lambda.